Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks problem of the day, and today's problem is find duplicate rows in a binary matrix, and it is a medium level problem. So a lot of people have been requesting for dark mode lately. So here it is. I personally don't find much difference between the two modes, but since you guys were requesting, that is why I changed the whole theme to dark mode. And let us quickly discuss today's problem of the day. So it says that we have been given a Boolean matrix, and Boolean matrix basically means all the values will either be 0 or 1. We have to find the indices of the duplicate rows. So for example, when we come to this particular index, if we consider 0 based indexing, this will be index 1 or row 1. We see that the elements are 1 0. The same elements are present before as well, that is 1 0, right? So what we do in this particular case, we push back the index of this particular row in our answer vector, that is row 1. Similarly, if we have a look at this particular test case, we see that 100 is present at index 1 and 100 is also present before it, right? So it does not have to be necessarily present just above it, it can be anywhere above it, right? Now in this particular case, this index is pushed, then this particular index is pushed because 000 is present before this particular row here, right? So this is how what the question wants, and there is a very simple method of solving this problem. What you can try to do is you can create a map, right, which is just going to store the whole vectors and store whether they are present or not. And I've initialized my answer with 0 here as well. So what I do for each matrix or each row, I just search it in the frequency map, right? So if this f dot find returns f dot n, that means this particular matrix or this particular row is not present in the map, and I mark it as present now, right? Otherwise, if it is already present, I just push back this ith position and return my answer vector. So this is one plain way of solving this particular problem. I'll tell you another way, but let me just quickly submit this problem before moving on to that particular method. So you see, this also passes all the test cases. This solution is absolutely correct. But let us discuss one very interesting method to solve this problem, and that is by using tries, right? So in this video, we're going to have a look at try, how to insert an element and how to search for elements. And I believe like this would be a high level explanation of how a try works, right? So it will be more helpful to you if you have a very basic idea of what try is, or if you have ever heard of it, or if you have tried reading or studying about tries, right? So if you are watching this video or watching a video on try for the very first time, you might find some things difficult, but I highly recommend you to watch this video again or watch some another video to understand tries better, right? Our focus will be to study tries in accordance to this particular question and how to solve this particular question with the tries, right? So let's say we have been given 100. So this is our row. When I see that this particular row, let's say, is not present in my try, I'm going to use it exactly like my map. And since in my map, if the row is not present in my map, I used to insert it, and if it is already present, I used to push that index into my answer vector. The same thing I'm going to do here is, so I need two operations, that is search and insert. These are the two operations I need to support for my try. So what is a try? Let's say this is a start node. This will be called my start node. From here I can pick two paths. So this can be 0 and this can be 1. Now from here again I can pick two paths like this. So these are forming different nodes, right? Now let's say we want to insert this particular row, that is 100. So how do we insert it? So what I'm going to do is I'm going to remove this part first. Let's say I'm at a start node, right? So I see that a node with 1 does not exist. That means there is a path going from 0, but there is not a path going from 1. So what I'll do, I'll create a path like this, and there will be a 0, right? Now I have a 0, so I will create a path like this, and there is a node like this, again 0, so I'll create a path like this, and then a node like this, right? So each leaf in this particular try represents one particular row, right? So that is 100, this is one row. If you just traverse the path and add all the elements along with that part, you will actually get the whole row. This is what a general try or a general try concept is, right? Similarly, let's say you had 101, so 1 will be here, then 0 will be here, and then you can easily form 1 like this, right? And now if you talk about this particular leaf, this leaf will be representing this particular row 101, right? So this is what we generally do in a try. So how does it help us? It really helps us to store the common prefixes, right? As you can see that 10 was common in both of these strings or both of these rows. So 10, it was common till here, right? So it helps us to save some space as well as save some time when we want to look for these common prefixes. In this particular case, we want to look for the whole string as well, and that should also work. So insertion is easy. You just go through all these values, and whichever node is not present, we are just going to create that particular node. So basically from this start node, you will have two next pointers, right? One will go towards 0 and one will go towards 1, right? So this 0 and 1 should have a pointer to some other node, right? If it does not have a pointer, we need to create it. If it already has, we just hop on to that particular node, right? So let's say now we create 1010, right? We want to create this particular row. So how do we do it? We start from here, we go to 1. Since it is already present, we are directly jump to it. Then we go to 0, then we go to 1. We're just directly making jumps. From here we want to have 0, but 0 is not present, so we are going to create a new node here. This is how it works. Now how to search for it, right? So let's say I want to search for 1010 only. I just keep on hopping to the next element, right? 10, then I find 1 and then I find 0, right? Let's say I wanted to search for 1011. So I will start from this particular start pointer, go to 1, right? From next element is 0, so I go to 0 here, then the next is 1, then I go to 1 here, and the next is 1 again. But since 1 is not present here, 1 is not present here, that means that particular row is not found in my try, right? So this is how you generally do it. I'll give you a very high level explanation of what a try is, how to insert and how to search. But if you're not able to understand it, you can either rewatch this particular part or look for some other tutorials which in depth discuss about try. So I'm going to implement try here live in front of you so that you get a better idea of how to think about a try, right? So let's say I have a class called node. So this is going to denote my try node, right? At each position, what do I need? I need a vector pointer, right, denoting the next position. Since let's say I have a constructor as well. So next is equals to vector of node pointers and the size is going to be 2, right? So what I have done here, I have just created a simple class called node. So this is going to denote by node. Now each node should have a next pointer, right, which is going to denote where is the next position going to go from here. Now for each next I need two positions. One will denote the 0 and the other will denote 1, right? So let me just re-initialize it with null pointer. So what will happen whenever I create a new node? Whenever I create a new node, it will have a next vector associated with it. Initially both 0 and 1 will be null here, right? So this is 0 and this is null and this vector is called next, right? Whenever I want to go from this particular position to a 0, I will create a new node and assign its address here, and for a 1 I will go to a new node and assign its address here, right? So this is how what I'm going to do. Now let me first create a root node. So it is going to be a root node pointer, and let's say this is called root. This is going to be new node, right? So this is how we just create a new root node. Now what I'm going to do is, for int I is equals to 0, I is less than n, since there are n rows, I plus plus, if not find let's say matrix of I, then insert matrix of I, otherwise answer dot pushback I. Now I also have to initialize my vector of answer, right? So now you see what I have done is, let's say let us also pass the number of columns here. This is the exact same thing that I was doing here. If my matrix is not found, I'm going to insert it. If it is found, I'm just going to push back this particular index. Let me just also return my answer vector, right? And let us move it for now and we'll look how we solve this. So now what I need to do is I need to implement this find and insert function. So let us first implement the find function. So it is going to return me a boolean variable. So let's say, and I receive a row. So it is going to be a vector of integer row, and it is going to return a boolean variable, right? So now what I do here is I'm going to go to all the elements and insert it, right? So my current node is going to be the root node because I'm starting from the root node, and I'm going to go through all the elements in the current row. So I is an m, I plus plus, right? So if current next and row of I is not equals to null pointer, that means if this particular position already exists, so I'm just going to set my current as current next of row of I. So if it is 0, so this row of I will be either 0 or 1. Now if this next is present of that particular 0, then I'm just going to update a current, right? Otherwise what I'm going to do is I'm going to create a new node, very simple this part, and I'm going to set current next row of I is equals to new node, and I'm going to set my current node as new node, right? So this is what we do. Okay, so this has not to be done. This was actually the insert part, so let me just create or change this to insert, right? So we only create a new node when we want to insert. In case of find, if we do not find that particular index, then we are just going to return 0. For now let us just change it to insert since I have written it. Now let me just verify it. So what we have done is we have taken a row as input, and we are taking the starting node as root node and storing it in current, right? Now I'm just traversing through all the values of the current row. If this next is not equals to null pointer, I'm just going to replace current by current next. If it is equals to null pointer, I'm going to create a new node and set that particular next of the current as new node and update my current as new node, right? So this is what we are going to do. Now let us implement the find function. So this is also very similar, not much of a difference. So we can also pass by reference here to avoid recopying of the rows. Now let me just, so what we can try to do is we can just copy this particular part. So you see now in the case of find, what we have to do is if we have found the next, then it is well and good, we move on to the next. Otherwise if we don't find it, we just return 0, and if we are able to find all the values, we just return 1 at the end. So this should return a boolean, and I believe that this is all, and let me just compile it and check whether this works or not. So we have got some compilation error. Okay, so node is private, we did not declare it public. So let's say we declare it public here and then try to run it. Okay, so this is line number 56, and line number 56 we have got some errors. Okay, so we have not included a semicolon basically. Okay, so this works for this particular test case. Let us just check one more. So this is 43100. Okay, so let me just put 000 here first, and then we will put 100 and then 000. So this was just to show you that the duplicate row that we are looking for should not necessarily be present just above it. It can be present anywhere before the current row. So you see, okay, so we have got only 2, we have not got 3. Okay, so 0, 1, 2. Yes, we should get both 2 and 3. Okay, basically we are not able to search for this particular row. That means there must have been some issue either with the find function or the insert. current is equals to current next. Okay. So I'm just going to print the current index. So I'm just trying to debug this, what is happening. So this got blocked at 0. Okay. This then the second one got blocked at 0. Okay. Oh, I believe that the dimension should be like this. I'm not sure whether this is the issue, but it is probable, I believe. Okay, so it is giving me segmentation fault now. So what is mn in here? They have defined r and c here, but they have defined mn in here, and I've taken n to be the number of rows. I just swap it. That should not be that. Okay, so now it is giving the correct output. I'm not sure if this is because of this. Yes. Okay, yeah. So the thing is, they have taken m to be the number of rows and n to be the number of columns, but I have taken the other way around. That is why it was giving error. So let me just remove this part and then try to submit it. So be careful with things like this. Although, let me just check this first. Yeah. So the thing is, they have taken RNC here and they have taken MNN here. Now I took n as the number of rows and m as the number of columns. Our try is perfectly fine. Let me just also submit this and then check. But the thing was, I was taking n to be the number of rows. So I had to swap these two numbers initially to get the correct output. So you see it passes all the test cases. The solution is absolutely correct. The try is also working perfectly fine. The only thing was the number of rows and the number of columns. So I hope that this part was clear to you. Again, I'm just quickly going through what is insert and what is find function. So in the insert function, we are looking for this particular element in current next. If it is equals to null pointer, that means that particular node is not present, and we have to create that node and set the next of that particular current as the new node. Otherwise, if it is already present and it is not equal to null pointer, we just directly jump to that particular node. In case of find, if it is equals to null pointer, we cannot do anything and we have to return 0. We cannot create a node here, we just have to find. That is why we return 0 from here. Otherwise, we jump to that particular node. So this is as simple as it looks now, and I hope that you guys were able to understand this particular solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.